Welcome back. How'd you go? Did you give the challenge a go? I finished the last video with issuing the challenge to index on X to return 9 and index on X to return 369. Now here's what I came up with. Again, there's a few different ways that you could approach both of these, but this is just what I've found. So because X is 133 of size, well that's its dimensions. If we want to select 9, we need 0, which is this first outer bracket to get all of these elements. And then we need 2 to select this bottom one here. And then we need this final 2 to select the second dimension of this bottom one here. And then for 369, we need all of the elements in the first dimension, all of the in the 0th dimension, all of the elements in the first dimension, and then we get 2, which is this 369 setup here. So that's how I would practice indexing. Start with whatever shape tensor you like, create it something like this, and then see how you can write different indexing to select whatever number you pick. So now let's move on to the next part, which is PyTorch, Tensors, and NumPy. So NumPy is a popular scientific, very popular. PyTorch actually requires NumPy when you install PyTorch. Popular scientific Python numerical computing library. That's a bit of a mouthful. And because of this, PyTorch has functionality to interact with it. So quite often, you might start off with, let's change this into Markdown. You might start off with your data, because it's numerical format, you might start off with data in NumPy, NumPy array, want in PyTorch tensor. Because your data might be represented by NumPy because it started in NumPy, but say you want to do some deep learning on it and you want to leverage PyTorch's deep learning capabilities, well, you might want to change your data from NumPy to a PyTorch tensor. And PyTorch has a method to do this, which is torch from NumPy, which will take in an ND array, which is NumPy's main data type, and change it into a torch tensor. We'll see this in a second. And then if you want to go from PyTorch tensor to NumPy because you want to use some sort of NumPy method, well, the method to do this is torch.tensor, and you can call .numpy on it. But this is all just talking about it in words. Let's see it in action. So NumPy array to tensor. Let's try this out first. So we'll import torch so we can run this cell on its own, and then import NumPy as NP, the common naming convention for NumPy. We're going to create an array in NumPy, and we're going to just put 1 to 8, A range. And then we're going to go tensor equals torch from NumPy, because we want to go from NumPy array to a torch tensor, so we use from NumPy, and then we pass in array. And then we have array and tensor. Wonderful. So there's our NumPy array and our torch tensor with the same data. But what you might notice here is that the dtype for the tensor is torch.float64. Now, why is this? It's because NumPy's default data type, dtype, is float64, whereas tensor, what have we discussed before? What's PyTorch's default data type? Float64. Well, that's not PyTorch's default data type. If we were to create torch A range 1.0 to 8.0, by default, PyTorch is going to create it in float32. So just be aware of that. If you are going from NumPy to PyTorch, the default NumPy data type is float64, and PyTorch reflects that data type when you use the from NumPy method. I wonder if there's a dtype. Can we go dtype equals torch.float32? Takes no keyword. Okay. But how could we change the data type here? Well, we could go type torch float32. Yeah, that will give us a tensor D type of float32 instead of float64. Beautiful. But I'll just keep that there so you know. Warning, when converting from NumPy PyTorch. PyTorch reflects NumPy's default data type of float64 unless specified otherwise. Because what have we discussed? When you're trying to perform certain calculations, you might run into a data type issue. So you might need to convert the type from float64 to float32. Now, let's see what happens. What do you think will happen if we change the array? We change the value of an array. Well, let's find out. So, change the value of array. The question is, what will this do to tensor? Because we've used the from NumPy method, do you think if we change the array, the tensor will change? So let's try this. Array equals array plus 1. So we're just adding 1 to every value in the array. Now, what is the array and the tensor going to look like? So array, we only change the first value there. Oh, sorry, we change every value because we have 1 to 7. Now it's 2, 3, 4, 5, 6, 7, 8. If we change the value from the array, it doesn't change the value of the tensor. So that's just something to keep in mind. If you use from NumPy, we get a new tensor in memory here. So the new tensor doesn't change if you change the original array. So now let's go from tensor to NumPy. If you wanted to go back to NumPy, tensor to NumPy array. So we'll start with the tensor. We could use the one we have right now, but we're going to create another one, but we'll create one of ones just for fun. One rhymes with fun. NumPy tensor equals, how do we go to NumPy? Well, we have torch.tensor.numpy, so we just simply call NumPy on here. And then we have tensor and NumPy tensor. What data type do you think the NumPy tensor is going to have? Because we've returned it to NumPy. PyTorch's default data type is float32. So if we change that to NumPy, what's going to be the dtype of the NumPy tensor? NumPy tensor.dtype. It reflects the original dtype of what you set the tensor as. So just keep that in mind. If you're going between PyTorch and NumPy, default data type of NumPy is float64, whereas the default data type of PyTorch is float32. So that may cause some errors if you're doing different kinds of calculations. Now, what do you think is going to happen if we went from our tensor to an array if we change the tensor? Change the tensor. What happens to NumPy tensor? So we go tensor equals tensor plus 1, and then we go NumPy tensor. Oh, we'll get tensor as well. So our tensor is now all 2s because we added 1 to the 1s, but our NumPy tensor remains the same, remains unchanged. So this means they don't share memory. So that's how we go in between PyTorch and NumPy. If you'd like to look up more, I'd encourage you to go PyTorch and NumPy. So warm up, NumPy, beginner. There's a fair few tutorials here on PyTorch. Because NumPy is so prevalent, they work pretty well together. So have a look at that. There's a lot going on there. There's a few more links I'd encourage you to check out, but we've covered some of the main ones that you'll see in practice. With that being said, let's now jump into the next video where we're going to have a look at the concept of reproducibility. And if you'd like to look that up, I'd encourage you to search PyTorch reproducibility and see what you can find. Otherwise, I'll see you in the next video.